chemistry is a lot of people don't understand that there's not one radiation detector that's fantastic for every type of radiation. When you have naturally occurring radioactive material, you're going to have alpha particles, beta particles, gamma rays, even sometimes neutrons if you're out in the uranium mine somewhere. And these require different types of detectors. So you got to make sure that you have the proper detector for what it is you're looking for. If you're looking for gamma rays coming out of some radium deposits, you're going to need something that's very good for detecting gamma radiation. If you're looking at lead-210 that's alpha and beta, you obviously need a detector that can detect the alpha and beta particles.
Yeah, and then on top of that, once you detect and get your readings on whatever it is, when you're going to take your samples, and then the lab analysis is really going to tell you the rate and the activity level.
Perfect. Sorry about that, folks. I think the screen is up for you now, and we can get back going. When you talk about measuring it, do the circumstances that it's measured matter?
Absolutely. We get asked a lot of times, people like Chris said, you're looking at specific activity. That comes into account when we get into waste a little bit later. We'll be talking about that. You can't go out there and directly measure specific activity with most handheld detectors. So people always want to know, well, can I correlate my readings walking up to a pile of pipe or a sediment inside a tank somewhere? And it's going to change. It's whatever the density of that material is in there. Or if you have one small pile of pipe you walk up to and get, say, 40 microarc per hour, now you have 3 small piles of pipe, you're not necessarily going to get 120 microarc per hour because you have 3. You still may only get 40. So it really depends on how big your sample is you're measuring, what your detector geometry is, how close are you to it. And so there's a lot of factors to come into play. So pretty much you just have to survey a lot to properly characterize something.
And to that point, especially when we do property surveys, everything, the environment and everything plays a part in it. If the grass is too tall, it's going to shield it. If your whole property is flooded, the water is going to shield your readings as well. And we've come across that a lot. So everything plays a part in it. So you really got to be specific on what you're looking for and how you're looking for it.
So we're going to come back to that because there's another place where I want to talk about, is it linear, is it not, but we'll come back to that. I think a lot of folks are going to be interested in the differences of downstream versus upstream, and is norm in those situations different? Does it act differently? Are they different isotopes? Do you survey it differently? And we'll get into more surveying, but
all of the above. As I said, when you pull the produced waters and such up, when you have the uranium and thorium deposits down in the geologic formation, the isotope or the element that's primarily soluble is going to be radium. So you get the isotopes of radium-226 and 228. That as you have that water start coming up closer to the surface and the pressure decreases, you start getting all your pipe scale deposits, your carbonate scales and other compounds. Those are going to have radium in them. So your radium gives off gamma radiation, which you can detect with a gamma scintillation detector on the outside of pipes. So you can find out just by walking up to some pipes that have pipe scale in and measure it from the outside whether or not there's some radium on the inside of that. As you start separating out your components, your light hydrocarbons, your heavy hydrocarbons, propane, ethane, propylene, and ethylene are the 4 main gases that are associated with the lead-210. Because radon gas is going to fall with those, and then due to the boiling points, it primarily flows with the C5 chains. So your propane line is going to have a lot of the radon gas with that. So your radium is going to be back at your production pads. You start getting the midstream, downstream, your gas line, hydrocarbon filters, your heat exchangers, you name anything in the downstream, you're going to have this fine layer of lead-210. It's probably mixed with a lot of your iron sulfide pipeline rouge. That stuff's real fun to handle too. And the only way you can detect that is it's alpha and beta emitting. So once you've degassed your lines and you pull equipment out, you need to have access to the inside of that because alpha and beta particles aren't coming through the steel pipe walls.
Yeah, that's what I was going to say. Is the farther it gets down the line in the refining process, the more it extracts, and the higher the different levels you get throughout the process in your filters and heat exchangers, and even coming out in your pigging all the way down.
So it concentrates down ultimately a little bit. Okay.
Right, and we've seen some issues kind of a little step further on that is somebody will measure the front end of a feed line and say they get 200 counts off some internal component there, then they assume that the rest of their plant's going to be less than that, when actually it's kind of the opposite. That's your feedstock, and as you start concentrating the propane, well, you're also concentrating the radon with that. So you may have components further into your process line that could be tens of thousands of counts when you walk up to them and measure them.
So I was going to address this later, but I think we should probably hit it now. When we're talking about counts, what are we talking about?
When you hold a detector up, depending on what detector you have will depend on how it reads out. When you're measuring gamma radiation and X radiation, you're typically going to be measuring exposure rate in microarc per hour. Everybody calls it dose rate. It's actually exposure rate, but it pretty much correlates 1-to-1 to true dose also. When you're looking at surface contamination, alpha and beta, you're going to have what typically people have a pancake detector. It's the trade name for it. It's a Geiger-Müller counter, gas field detector, and you get counts on that. So you have to take in detector efficiency, detector geometry, how big is your detector face compared to, because regulatory limits are expressed in units of 100 square centimeters, and our detectors aren't 100 square centimeters. So there's some conversions you have to do. So usually when you're out there just doing a raw count, all you're getting are counts, and your detector literally has CPM, counts per minute, as its unit of measure.
And then when we talk about actual sampling, those concentrations are in
picocuries per gram.
Okay. All right. So they aren't the same necessarily either, right?
One's the rate and one's the activity.
Okay. So we'll get into that some more too as we go through this.
It's because you keep clicking on the other
stuff.
Maybe.
My presentation isn't jiving with my mouse. So one of the bigger things here, I think when we start talking about norm, is there's some pretty strict standards to the requirements, right? And so, Chris, when we talk about the requirements, what do we have to have when we're dealing with norm, or when we're at a site that we're looking for or at norm?
So you're always going to have your minimum level C PPE, which is your respirator, your Tyvek, your gloves, and your rubber boots, and your dosimetry. That's just standard walking in just to survey something and potentially clean some stuff up. Whenever you get into higher levels or quote unquote dirtier type jobs, you're going to increase the PPE either to supplied air or to your Ty-Chem suits that are a little stronger to keep the norm from getting to your clothing and on you.
And then when we talk about, there are other requirements with doing work at a facility. When we talk about those, Don, what else do we need?
So, and that's going to depend on state to state also,
okay,
what they call licensed activity. So generally speaking, if you're performing any type of decontamination, virtually any state that has norm-specific regulations will call that licensed activity, meaning you have to be a licensed contractor to do that work. We have licenses in Texas, Louisiana, Mississippi. If we're going in another state, we actually have to contact that state service and say, hey, we're going to come do similar activities in your state, and file what's called a request for reciprocity. And there's a lot of confusion because the regulations aren't very clear on what's considered decontamination. And we go back and forth on that every year between regulators and contractors, and it's still kind of a gray area. They basically throw some blanket statements in there and leave it up to us to figure out, do we need to notify the state we're going to do the activities or not. Some states require you to get reciprocity even if you're just performing any type of service. So you could be out there in their state doing just a survey and have to be a licensed contractor to do that. So it really depends on what state you're in. But like I said, general statement, if you're doing any type of decontamination, that's licensed activity virtually everywhere you go.
And so when we go into this, what's the role of a radiation safety officer or RSO in those types of activities?
So your RSO is going to be the one he's making sure that your crew and the job site is going by that state's regulations, like Don was saying. He's going to be the one that's making sure that your barricades are up, that your decon area is up to code, and that nobody's coming in and out of the zone contaminated and spreading their contamination. He's making sure that all the paperwork is, all his I's are dotted and T's are crossed, because if any state, if OSHA wanted to come out and check on anything and one thing was out of line, then the whole job would get shut down for that, just for missing something even so small.
So Lynn, I think I know this one. One of the bigger problems with radiation and norm in general is cross-contamination, going in and out of the exclusion zones. Is that accurate? Or?
Right. Yeah, you don't want material coming out of a restricted area. You want to keep the contaminant. And this is pretty much the same for any hazardous material. You want to define where is my hazard area and make sure that all your hazardous material stays within that area. So we're going to check everybody and every component coming out of that restricted area and make sure you're not spreading contamination somewhere.
So this is funny. As I went back and looked at my notes, I realized through the whole thing I never did ask, who regulates this stuff? And let's try and stick to Texas for right now, because I know this is going to vary. But in Texas, who regulates this stuff?
Depends on what industry you're in.
I have a feeling this is going to be the answer.
I joked with you. The answer to every question is always, it depends. So Texas has Texas Railroad Commission, Texas Department of State Health Services, and a Texas TCEQ all have a hand in it. And it really depends exactly what type of facility you're on and what you're doing. So if you're out on a mine site or on your production pad, that's generally going to be Texas Railroad Commission. And if you're out midstream, downstream, and again, it depends on, are you talking natural gas or are you talking crude oil, because it even changes between those two.
Because there's a division line
between
the two agencies, right?
And where it really makes a difference, because TCQ and DSHS have a memorandum of understanding that says, although we regulate the waste and landfills and such, we're going to go by DSHS standards, which are published. Road Commission, more or less, does the same. There's a few changes in the regulations where somebody has an and instead of an or that make a difference on disposal concentrations.
So I'm not a consultant anymore, so I get to say this. I mean, it's surely a one-page document from the Railroad Commission. I mean, I know how this stuff goes, right? Like,
is it a full page? It's a website with some links, and they even reference TCQ and DSHS. But yeah, I mean, you can go look up the Texas code for all the Railroad Commission rules, but a lot of it generally goes back to DSHS. They're the ones responsible for licensing. Neither of the other two groups write licenses.
Gotcha. All right. So shifting gears here a little, I always like to ask the so what question, right? We can regulate whatever we want in this world, but why or what's the difference? So when we talk about norm, what's the biggest exposure pathways? What are those?
Inhalation and ingestion are the top ones. So obviously that's why the PPE is so important, because the alpha beta particles are going to go into your lungs, and they're the bone seekers that are going to go in there and stick, and potential carcinogen over a longer period of time. And then your gamma is going to basically go through you regardless, and that's why the shielding is important on that.
So maybe this is a dumb question, but have you ever seen someone get sick from norm? Is that
So the biggest concern is going to be small chronic intakes over time. There's nothing in a norm field that you're going to walk up and have some sort of acute, oh my God, I was exposed to some pipe scale, my hair's falling off, I'm getting blisters. don't believe what you see in Hollywood.
This is not a Chernobyl kind of thing.
Right.
This is a chronic, long-term.
Right. So where we see the issues are, and I did a lot of litigation support before I came to work for USA, and where the problems come in is, there's a 1 in 4, 1 in 5 just natural cancer rate in the U.S. So a lot of it comes down to your risk at your company. If you got a guy that maybe he smokes 2 or 3 packs of cigarettes a day and gets lung cancer, 5, 6, 10, 12 years, however long down the road, he comes back and says, well, I remember working for company X that had no radiation safety plan, and one day I remember getting that norm on my face, and they found out I inhaled some of that. And when you sit in front of a jury, if you mention the word radiation, you lost. So you want to make sure you don't get to that point.
So this is really a case where, and I don't want to belittle the worker health and safety, but from the corporate level, this is really an area where you're showing that you didn't expose somebody,
right,
so you can get out of a claim potentially later on in life from potentially a natural occurrence of something.
Yeah. So, Chris mentioned the dosimetry, and, we do monitoring and the surveys. And a lot of times people ask us, why do you do that when, you can't even pick up this radiation alpha beta on a dosimeter? It's like, well, it's never bad to document zeros. One, you want to make sure your guys aren't getting exposed to stuff. And kind of back on the alpha and beta, alpha particles have what we call a quality factor. And without getting into a 2-hour lecture on radiation physics, the quality factor for alpha radiation is 20 compared to gamma and beta, which is 1. So essentially what that's saying is, for the same amount of material inside your body, alpha particles can cause 20 times the damage, have the potential to cause that. So, a lot of this naturally occurring material is alpha particles. The lead-210, the polonium-210, those decay products, those are all alpha and beta. So you absolutely do not want that inside your lungs and contact the soft tissue. So we're not going to say that you can never have any effect, but you're just not going to see acute effects, which are typically what people associate with radiation. But when you start getting into the litigation side of it, you're looking at long-term effects, and somebody has some other effect down the road, and you want to make sure that you documented everything properly. So it's really crucial that you have a good radiation safety program. Yep.
So it sounds like with exposure, there's a real importance on the dosimetry that you're getting also. And do you guys measure that as you go through this?
So whenever we get the dosimetry, and each one's designated per person, so that that everybody's covered on their own level. So we get them quarterly for us, but once we turn that in, they will analyze it, and they'll send you back the report on what the readings they had found on that person's exposure for that quarter, and then you keep those for, I think it's like 30 years, 7 years or something. And so that way, if it does come up that they think they got cancer from norm, you just show them the paper and say, this is their exposure, and this has nothing to correlate with that.
Well, so we're going to get into some of the sites I've seen, but when I see the guys out knocking scale off every pipe that don't work for a licensed company or have any dosimetry on, that's sort of a bad thing.
Yeah.
Right?
Yeah, and not everyone working with radioactive material will have dosimeters. We badge a certain portion of our workforce. The guys that are doing, working on my projects every day, they're working down with thorium, some of the gamma emitting stuff. Those guys are going to be badged. Some of the other workers, but again, you're going to have some other means of assessing what were they exposed to. We're going to be doing air monitoring. You talked about respirator usage. Depending on what conditions are, your guys most likely are going to be in respirators. So you're going to have a lot of other documentation. If somebody does get some sort of suspected intake, meaning somebody came out of a controlled area and you detect radioactive material on their face or on the respirator, and do what we call a nasal swab. Everybody knows what a nasal swab is now.
Yeah.
we used to have to explain what that was. Now everybody knows what it is. We don't quite go to the brain stem like the COVID test, but you're going to check the nasal passages, bring it over on the detector, and all you're looking for is, did they potentially get radioactive material as an inhalation? If that's the case, sometimes we'll do what we call a bioassay. You hand them a milk jug and tell them to fill it with all their urine for the next 24 hours, and we send that off to a lab. And we're trying to see if they had enough material in their body that it's now being excreted, then you can back calculate what the actual internal dose was for that.
Gotcha. Well, so let's shift gears here a little more and talk about how we actually survey and do testing for norm. And so I remember also when I was a consultant, I didn't work around a lot of radiation, but we did do some, and I would wear a ring
Right.
to I think it's sun exposure, right? And we're trying to get a background or something like that.
No, there's different types of dosimeters, and depending, usually those are with certain types of equipment. If you were using XRF.
Oh, it's the XRF.
X-ray.
Okay.
Yeah, if you had an X-ray fluorescence device, you most likely were required to have what they call finger dosimetry, because while you're holding that gun, your hands are 6 inches from what you're shooting. You get scattered radiation.
Gotcha.
Generally speaking, badging for people just out in the workplace are called whole body dosimeters. They wear them somewhere between the waist and the shoulders on their chest.
Nice. All right, so you have a site. Somebody asks if they have norm. Chris, where do you start?
Well, it depends. Is there a big pile of dirt? Is there a pipe that's just laying there in the ditch somewhere? We've come across plenty. Is it a scrap metal pile? Is it sludge in a pit? So first you want to assess what you're going to survey, and then once you realize what kind of material it is, that you can do your next steps into which probe you're going to use, which there's tons of different types of meters you can use. We generally use the Loveland 3s with the scintillator and the pancake probe. So once you decide and you know what your media is going to be, then you can go in. So if it's a pile of powder, you're going to use a pancake probe, because the game is either going to be already gone because of the half-life, depending on what it was, or you're not going to get an accurate reading on that you would with the pancake probe.
But in general, you start with probes and counts as opposed to sampling and.
Yeah, it depends. Like, first thing is you talk to the client, and you get the best available knowledge. What are we going to? Is this an oil and gas pipe yard that we know has pipe scale and production fluids that came up? Because then you're looking for radium-226 is going to be your prime nuclide of concern. That's a gamma detector, so you may start with a 4411, 44.2 gamma scintillation detector. Or like I said, if it's a pile of pipeline rouge or a pigging line on a propane feed or some Y-grade field gas that pushed out a 6-inch Tootsie Roll looking thing of sludge, you're going to have the gamma scintillation also, because some of the short-lived isotopes can give you pretty high exposure rates off of those until they decay way over 10 to 12 hours. But then if you had high exposure rates, you're going to have a lot of surface activity and specific activity from the lead-210. So again, the 44.9 he was talking about, pancake Geiger counters, is pretty good. It'll respond to all the types of radiation. You're only about, depending how good a condition your probe is, between 1.5% and 3% efficient for gamma radiation. So it's not. That's why we have specific gamma detectors for if you're really going out wanting to know, all right, what is my true exposure rate from gamma? You're not going to walk up with a pancake probe. But certainly for the alpha beta stuff, it's great. And again, it'll respond to everything. So if you get a response and you look at what it is, you kind of assess, what am I detecting? We also have detectors, field detectors, that will do isotope identification. We get called out. Our license isn't just norm. We cover any atomic numbers 1 to 95. So sometimes we get called out and you don't know what you have. Somebody dug something up. In fact, we worked together at a previous company, Chris and I, where somebody was doing hurricane cleanup, went to a landfill and set off the detectors. And, you get used to the calls from landfills, and usually they don't understand the units on their detectors. So when somebody says, I pegged my detector out, you're like, okay, well, you on to 0.1?
Yeah, it's going to pick up air.
Then it turns out this one actually was pretty zippy, and that's a technical term. And, it turns out somebody, best we can guess, back in the 60s, dumped a cesium source in a ditch somewhere, and it got breached when they came in and built the subdivisions and laid the water lines and spread it down an entire ditch. And this is,
the neighborhood was getting sick, and it was crazy.
It was, and they were.
It took us forever to find that thing.
Yeah, they were high activities. I mean, we had like 200, 250 millicuries just open, sitting in a ditch underneath a water line. So in those cases, you go out there and, you can look there and say, oh my God, I'm getting exposure rates in the hundreds of MR per hour. That's not normal. So now the question is, well, if it's not normal, what is it? So that's when it's nice to kind of have some field capability to say, all right, it's cesium. Now you start asking different questions.
So do you always stick with specific probes, or is there a time that you use the the probes and then switch over to a sampling kind of regime to ground truth, or is that not really done?
If you're going to dispose of something, you're always going to have to go sample it. You can't really. There's some detectors you can go out there, but it takes a lot of programming to get it to tell you what your specific activity is. And those are expensive. It takes a while. It's much better just to go pull a sample, send it off for off-site lab analysis to get the specific activity in picocuries per gram.
Gotcha. And so ultimately, we use different detectors. We use different sampling stuff. So we talked about this question, and I told you guys I was going to ask it. So I've got 3 piles, and they're 30. They're 30 and 30 and 30. If I put the piles together, is it still 30? Is it 90? Or is it everywhere in between?
Yeah, as we discussed, it really depends on, like, you may be getting 30 on one pile because you can't get all the way through the depth of the dirt to figure out if it is actually 30. But for all sakes and purposes, if they are all true 30 and you combine them all together, then you're going to get about the same activity level, but you won't really know what is what until you do the sampling and all that. And it doesn't necessarily increase the, there are cases where it can increase with more of the contaminated soil being added together, but sometimes not so much. And Don can elaborate on that with the science.
Yeah, and again, it depends on, you hear me mention geometry effects. If you look up the regulations, you'll see a little blanket statement underneath the limits where it says must take into account geometry corrections. So that's what they're talking about, is your detector face size to the area you're surveying. So back to your example, if I got 3 piles, well, how big are the piles? If we're talking 3 sample jars on a table, each one being 30 microarc per hour, and you put them right next to each other, you probably will see close to 90 on 3 of them. If you have 3 roll-off boxes all reading 30 microarc per hour at 2 feet from them, and you stick them all together, you probably won't see, you may see a slight increase. If you walk in between 2 of them, you'll see more or less double, because now you're getting the same radiation field from 2 sides.
So surface area plays a role here. That's a geometry. That's what you're sort of talking about.
It's more the surface area detector to source ratio is kind of what you're really looking at.
Gotcha.
Consistent distance.
Yeah.
But that's the important part, though, too, right? Because that's actual radiation hitting you, the detector, everything else, right?
And that goes back to, when people want to know, well, can I just go do a field measurement with a survey instrument and know what my specific activity concentrations are for waste? It's like, well, probably not. If you have enough data on those type tanks and all of them were, had 2 feet of sediment with the exact same density, then yes, you can, but that never happened.
Well, now, I know we have some oil and gas folks on, because I've seen the list, so I want them to listen to this closely. The same well can produce different things at different times, right? And that's why they get mad when this happens, right?
But it happened before, and it's like, well,
yeah,
happened now.
Yeah, we see that all the time. You can be on the same production field, 8 different wells, and 2 will have norm and 6 won't. You come back 2 years later, maybe 3 do and the others don't, and it may not even be part of the same 2. So again, I don't know what's happening down in the formation. Everyone always has this conceptual idea that's not actually in the oil and gas, that you drill a hole and it's this big giant cavern void full of oil. The dinosaurs and vegetation died billions of years ago and turned into a big puddle of oil. And that's simply not the case. It's a bunch of porous rock that you're forcing the stuff out with pressure. And so I don't know what all goes on down at however deep you're drilling, but again, it goes back to the actual, usually it's uranium and thorium, the primordial isotopes that are down there in the formation, and it's getting the radium that's soluble in the produced waters. And I'm sure it has to do with flow, pressure, temperature, and
well, and it could also have to do, from what you guys are telling me, like solids in the tank and different things like buildup of solids over time.
Concentration of it, just like in your pipelines, your main concentrations are going to be where it collects, mostly in your welds, your filters, and your valves, and that's why a lot of valves.
Yeah, change in flow is what I usually tell people. Where you have a change in flow, if you have 2 miles of laminar pipe, it's usually fairly uniform. And all of a sudden you go from an 8-inch pipe through a reducing valve to a 4-inch pipe or a Y, you're going to see eddy currents in your flow, and you're going to have the deposits right there. And the other thing comes up is sour gas versus sweet gas. There's some misconceptions on there. People have a line that'll have a lot of pipeline rouge in it, and they know that a pipeline rouge often will have norm in it. Because when you create the lead-210, when the radon decays, it creates one atom at a time, and it will stick to particles within that stream, just electrostatic, just like they talked about the COVID virus sticking to water molecules, kind of the same concept. And so you get those trapped in your pipeline rouge filters, but that doesn't mean that every time you find pipeline rouge, it's always going to be radioactive. And it doesn't mean if you don't have rouge, it's not going to be radioactive. In fact, the ones that don't have rouge, a lot of times are higher in radioactivity than the other ones for a couple reasons. One, you're plating out pure lead-210 on the inside of that pipeline component. The other thing is, if it's one that doesn't have a lot of buildup, we find they don't tend to get cleaned as often. People aren't running their pigging tools as much. People aren't pulling their pumps and their exchangers as often because they don't get fouled. The reason they pull them is because they see a drop in efficiency in their plant. They're not going out there and cutting a cube. Yeah, they're not going out there cutting a coupon out looking for norm. If it doesn't affect their productivity, it's not an issue.
We've seen the cleanest stainless pipes that are still polished, and those can be the hottest things you see. It doesn't necessarily have to be, because your atoms are going to be, you can't see them, so the activity in there is still just as high.
Gotcha. I want to hit on, I think this is probably not the sexy part of norm. You consider any part of norm sexy, but scrap metal in recycling and yards. I mean, this is a huge business, and it's a fairly significant problem, I think, right? I've noticed lots of scrap yards are starting to put detectors up, and lots of people are getting rejected. Are there regulations in this area? Is there?
There are, and as you said, it's kind of a nightmare sometimes. Places that used to accept it don't anymore, and I've talked to several scrap dealers, and where you see problems is you get into the Texas regulations, and you see them talk about oil and gas, and all of a sudden you see a distinction. All of a sudden they talk about gas. And that's where they're talking about the midstream, downstream, and the lead-210 versus the radium scale and such. And that goes back to the fundamental concept that if you only have lead-210 in its decay products, you typically just have alpha and beta, which you're not going to pick up on these gate monitors that places have. And you get to the regulations, and it starts talking about scrap. And when you're looking at oil field production pad stuff, they have 50 microar per hour. If you're less than that, including background measurements, you're exempt. You can go throw that in a landfill for disposal. But that only applies to oil and gas. So when you look at gas lines only, all of a sudden you lose that because there is no gamma component. Now you go back to recycling and they fall back on that 50 microar per hour again. But yet people are taking stuff that could be completely crapped up with lead-210, send it to a scrapyard,
trying to
just not even disclose it.
Trying to fit a square hole in a round peg with a regulation.
But then you get another set of regulations about unrestricted release of items off your facility, and now you have these surface activity limits, and people think that, I'm sending it to a recycler, those don't apply, just recycling. It's like, well, wait a second, you're still going to have people handling that. How are you going to explain that to the scrapyard guy when he actually walks out there? And this is what you alluded to, guys. Well, now if they don't have gate monitors, sometimes even with gate monitors, they will still go out and hand frisk some of these items in a few spots. And if it's over background, it gets rejected. They don't look up regulations. They just say, all right, I'm getting 36 counts over here. I'm getting 400 on yours. Don't want it. So if you can demonstrate that your scrap product, after it's been melted down, is less than the exemption criteria, you can still accept that. Now, how many scrap dealers are really going to make those calculations?
Yeah.
And from what they explained to me is that they don't want it regardless because, one, they have to resell the material. And nobody wants to try and sell a product. It's like, hey, Chris, I got 20 tons with nominal radioactivity, but it's exempt. And a competitor down the road has some pristine, clean stuff, but I'll give you a 5% discount. But nobody wants that. Then the other thing is when you remelt and you have these norm atoms that are in there, they're not going to typically end up in your metal product. They're going to end up in your slag. Now it's back to that concentrating effect, that now you're scraping the slag off, and now you may have concentrated those radioisotopes in that, and you may have a regulated waste now at your scrap melting facility. Nobody wants to be stuck with that.
That you didn't have before. I mean, I've heard from scrap yards that the scrap goes in there and then they install the meters or the gateways, and now they can't let it come back out. And now it's stuck in there, and then they have these big piles of scrap metal they can't do anything with, and they're just going to sit there until someone either comes in and cleans it or.
So we've hit a bunch of the oil and gas up and down. And we need to move on from this section, but I want to ask, where's the most unusual place that you found, Norm?
Wow, unusual. I mean, a client didn't disclose it was there?
No. So I think of the one project I've seen that I hadn't thought of. Like, we found a frac sand yard that had a lot of norm in the frac sand, and something I would have never really thought about.
That would have been the first place I looked.
Oh, yeah.
One of the interesting ones was we were cleaning a facility that had processed thorium, old welding rods and a bunch of stuff like that that had just natural thoriated metals, Mag-Thor alloys, thorium molding rods. And we kept getting hits outside the fence line in the front ditch. And nobody could figure out what it was. It's like, they actually had a pretty good practice. We were just handling all this waste and had to do the closeout surveys for them to decommission their license. And we kept finding this, and we finally found out it was a city water line prior to water treatment that had been leaking for 10 years. And wherever they were pulling the groundwater up from just had dissolved uranium in it. And it created this kind of norm plume in a ditch out front of their facility. So we had to collect all sorts of samples, and submit it to the state. And they finally sent their person out to investigate it, and they had their detectors. They pulled their own samples, and oh my God, 3 months, 4 months later, everybody agreed, yes, this is due to the water that was leaking. Has nothing to do with your facility. It's different isotope.
Yeah, I'd probably say the craziest thing was the ditch that we mentioned earlier that somehow got traced back to it.
The cesium.
Yeah. Another non-norm.
Yeah. Well, so hitting a few more interesting sites, and maybe not all the bad ones. We talked yesterday about oil sands. That's a common place for norm too. Yeah,
the oil sands. And, somebody's always coming along trying to look at how they can reprocess that oil sand to extract the oil out. And oftentimes the cost of doing that isn't worth what you're getting from the oil. Most of the advances I've seen in that were over in the Middle East. And when I was over there, we met with a group. We're trying to work with them on doing some norm waste importation from overseas into Texas. And they were showing me their facility, and these ponds were nasty looking. They were awful. And they had 6-7 feet of just the nastiest oil sludge in them, and they had a lot of radium in that. And they were, you look at it afterwards, and it was just this nice, clean, dry sand, really powdery sand out of that, and they extracted the oil out of it, and they were basically getting break even on the cost of that. So the problem was they didn't have a disposal option at the time, but I helped pave the way when I was with USA to get some import lines open for that, so they could actually take that stuff to Texas and dispose of it. But yeah, people always look at cleaning something up, and you always have to look at your waste products you're producing from that, because everything's been dumped into those waste pits over the years, included your radioactive sands coming up with your hydrocarbon.
Go ahead.
I was going to say it's the same thing with the frac sand yard that we found. It was just big mountains of frac sand, and we did the survey, and they'd have all these super sacks of who knew what was in them. Those are our highest readings, but they're all cut open, spilled on the ground, and they just put a fence around this property and said, "Oh, it's just a site now."
Do you two find that most of the folks that call you on norm, do they have corporate policies around the waste, around the norm, around the?
They basically call us to see if we can turnkey. Just do it.
So most of them don't have any kind of.
They don't have an idea of what to even look at or for. And
they'll have them, but they're generally inadequate.
Just something off of like the OSHA site or.
Yeah, they went up, looked up. What is it? OGP 12 publication, oil and gas production. Publication number 12 is basic components of a norm program.
It just says there's norm somewhere.
And that was really designed for states and other entities to follow in getting regulations, not necessarily for a single entity to go in there and say, "Oh, we're an oil and gas producer. Here's our program." But they're getting a lot better. I've been doing this, oh my God, 24, 25 years specifically for NORM. I've been working with radioactive materials since the 1990s, and you see cycles. They get better, then they start getting lax, and they start getting a little better, and they start getting lax. So a lot of companies are really trying to do the proper thing now, as compared to early on, early 2000s. It was who can get away with what.
It's a little bit of the pressure on you two, right? I assume you're on the firm's licenses, right? And you have to go work with folks that might have a policy, but it's not really a policy.
A lot more responsibility and consequences that come towards us.
Yeah, I mean, you look up all USA's licenses, and you'll see my name on them. So if something happens and somebody does something wrong, my name's included in that.
Because we know better.
Yeah. I'm a certified health physicist, so that has other weight that adds on that. It's kind of like any other certified person out there. That you have obligations, and it might not be the answer a client wants to hear. That I'm sorry that cost $200,000 to dispose of, but here's your options, and this is what you're being faced with. But if we go in there and try and help them with, how can we change this process you're doing to help eliminate or help reduce those costs?
Sure. Well, so while we're on the waste and the liability side of things, so transporting, are there special requirements with transporting, Norm?
Yeah, depending on the material you're transporting, depending on the readings you are getting from that even. So like when we transport a roll-off box of contaminated soil, you have to have your bill of lading, and you're going to have to go around, and you're going to check 3 feet from and check with your meter, because as you're driving down the highway, you're going to be exposing doses to people that are sitting in the lane next to you at a red light. So there's all kinds of placarding. You have to have that radiation survey with the driver, so that if in the event they get pulled over, they can see that it's been surveyed and they know what the dose rate is coming off of that. And I let Don get into more of the.
Well, so take it at different levels here. There's different transport.
Yeah, there's a lot of options, and DOT actually made it pretty nice for NORM. Is they came up with the whole LSA, low specific activity, and SCO, surface contaminated object. UN 2912, 2913 hazard codes, and they gave you kind of some options. So a lot of times, when people think of radioactive waste, they have these visions of these drums with these big radiation symbols, and they're hot to touch.
Like Back to the Future.
And yeah, you can certainly drum waste up, but like Chris said, if you have roll-offs full of soil, you don't want to put those in thousands of drums. So you do bulk loads for those. So we get a lot of leeway on the LSA class in that you can put it in what they call an uncontainerized load. So your roll-off box, your in-dump truck becomes your container essentially, but it's what they call an uncontainerized load. So you can transport it like that, simply tarp it so it prevents contamination in your roadways and your vehicle under normal conditions. But in return for that, DOT says you're going to do it that way. Well, now you have to placard that load. So now you're running a placarded load. So now that kicks in a lot of the other DOT requirements as far as, the type of manifest, weigh stations, documentation you have to have. The 1 meter exposure rate, dose rate is called a transport index. If you put a yellow 2 transport label on a container, you're required to do a surface and a 1 meter exposure rate measurement to verify that you're within those limits. Same with the LSA. You have to have your dose to the guy driving that. You have to be less than 2 mR per hour for the person that's in that cab, because he's sitting there all the time and he's a member of the public. So your 2 millirem in any 1 hour is going to be your limit for that guy. And you go look up the regulations, and people they're interesting when you look at the LSA. It's like 1 R per hour uncontainerized, and you're like, oh my gosh, that's well, again, that regulatory category for transport is meant for all diffuse radioactive material, not just NORM. So
Gotcha.
Sometimes people bring in other type materials, and again, that's unshielded. So that may be your limit for an unshielded source. That doesn't mean you can just throw it in the back of a truck. You may still have to include shielding with that. So
Gotcha.
Again, the DOT there's a lot of small regulations, the marking, the labeling, the placarding. We'd spend hours just discussing that in detail.
So there aren't actually that many places that you can dispose of NORM. Is that accurate?
Probably count on one hand the amount there's places in Texas, there's Idaho and Tennessee, I think. But yeah, so since there aren't a whole lot that take that kind of thing, and depending on your activity level with your lab data, it gets very pricey because they're the only ones that do take it, and then that's where people don't want to do it the right way, is because it costs $1.
Well, and this is the lesson towards know where the norm is early, so you don't knock all the pipe scale off and have to take the soil up with the pipe scale too, right?
And that's where we really encourage clients to say, don't wait till the end to bring us in to manage your waste. Bring us in the beginning
To minimize
minimize what you're generating.
Because then you got to dig up the dirt that the scale fell on, and
Yeah, and we've seen. I'm sure we'll get to that in the good, the bad, the ugly section. But
so do we follow the TCEQ waste classification guide to classify norm, or do we follow somebody else's classification guide?
so again, you have options.
Okay.
And if you can class it as E&P waste, exploration production, then you can follow some of the Railroad Commission rules, and you can send that to an injection well. And you essentially have unlimited activity. The well has some requirements in their permitting for the Railroad Commission as far as, their permit's not going to say you can inject 6 million picocuries per gram radium-226 down your well. What they will say is you can mix somebody's 2 drums of 6 million picocuries per gram with 200,000 cubic yards of non-radium impacted E&P waste to make sure that your overall concentration in your well is below that. But generally speaking, how it affects the end user and the clients is that essentially you can have unlimited activity for that, except it has to be classed as E&P. Now you get back to where are you in your process. If you're downstream in the chemical refineries, you don't have that option. Now it comes back to exemption categories. Can you meet the Texas exemption criteria for disposal inside of Texas? If you can, you're golden, unless it has other hazards.
Well, so I was just going to ask, sounds like a really bad idea to mix norm with a has waste. Can you even get rid of that kind of stuff?
Even if you do, that's very, very pricey.
Yeah, we're dealing with several of those right now that, unfortunately, some past practices weren't the best that the client did, and it was bad information they received from some other people that were helping them out. But now here you are, 8-9 years later, and all of a sudden you're checking some stuff, and it was just things that you don't really think about, stuff leaching out of solids into liquids because they've been stored that way for however many years. So maybe it wasn't quite hazardous now, but now that you have to separate your solids from your liquids for disposal, now you're analyzing them independently, and all of a sudden, lo and behold, your liquids changed. And now you have to deal with that. Yeah, if you don't meet the exemption criteria in Texas, now you're forced to go out of state, and your options are limited. And now you add something like, lead. We talked about this stuff as lead-210. If you have high enough activity, people seem to forget that lead's also a listed hazardous material. So if you have waste that's high in lead, boom, you're hazardous waste too.
Okay, so we have some questions. We'll go over those. I'm gonna get the ancillaries out of the way, and then we'll hit some questions. We're running a couple minutes behind here. So Icon Environmental Solutions LP is a leader in environmental service, industrial containerization, waste management, cleanup, civil contracting in the waste management field. Icon was founded in Houston, Texas in 2009 to serve the growing demand for highly qualified environmental and heavy civil contracting services. Icon offers proven safety performance, a proven project delivery team with a combined 200 plus years of relevant experience. I'm going to cut that a little short. A few of you have heard it before. And for Don, thank you for being with us. USA Environment LP has been a turnkey provider of remediation and industrial services across North America, specializing in radiological impacted sites. Each radiological business unit is managed by ABHP. Thank you. Certified health physicists. Our licenses allow us to manage radioactive materials, atomic numbers 1 through 95, in any quantity required for the site, from development of remedial action plans to final status closure under MRSA requirements. USA can provide it. Our norm services include equipment and facility decontamination, land remediation, turnaround norm management, site decommissioning and waste characterization and disposal. We are also excited, this is brand new, hot off the press.
That's right.
We are also excited to announce our acquisition by Intact LLP. We are looking forward to applying our combined strength and experience to Intact, providing quality client services.
That's right. Two days now we merged with Intact LLC, and you heard it here first. That's right.
Hot off the presses.
Now we're up to almost 1,000 people total. So.
Nice. So our next webinar in the series here, working backwards, civil construction projects that become environmental projects. Join us on November 17th with civil expert Ray Garza, John Savage, and Greg Bloomquist for a discussion on when civil projects turn into environmental projects and the problems and differences that can ensue. That QR code up there, if you scan it with your phone, it will take you to the registration page if you so choose. You'll also get a copy of this. So with that, there is mine and Chris and Don's contact info. Please feel free to reach out if you have questions you don't want to ask here, but I have a couple questions actually. We got about 2 minutes, so we'll answer some questions. We'll stay a little late if you so please stay on the line, and if you need to go, we understand. So question from the audience, what is T-norm?
So that depends what state you're in.
Okay.
So that goes back to regulatory classifications. And, if you really look up the Texas regulations, norm and T-norm is actually part of the NARM, natural and accelerator produced radioactive material. How those two got combined, I don't know. So the way you usually look at it is when it's sitting there native in the ground, it's norm. Once you've moved it, enhanced it, consolidated, concentrated, whatever, now it becomes T-norm. A lot of states will go back and forth synonymously between norm and T-norm. In Texas, depending which set of regulations you're looking in, they refer to it as norm in one spot, T-norm in the other. Really, everything we're dealing with is truly T-norm. It's technologically enhanced norm, but everyone calls it norm.
Yeah.
Okay.
It's a broad umbrella.
So I'm going to ask a follow-up for the asker because it's on my mind. You could technically, it's bad for you if you keep enriching norm, right? Because it becomes more and more difficult to get rid of. Am I wrong there?
Yeah. It can change characteristics a lot depending on what you're adding to it, what you're doing to it, how you're refining it.
Higher the activity, the more challenging it is to manage, more challenging it is to stop cross-contamination, the more expensive it gets to dispose of it.
So another question that we've got, iron sulfide mixed with norm. There's a fire risk in here. Right. I'm assuming is probably what they're thinking.
Right.
They want you to expand upon that.
So that's
how we deal with it.
That's a great one because that comes up pretty often. Now we get into the good, the bad, the ugly.
Yeah.
So what a lot of people will do is they'll take a drum, they'll fill it full of water, and they'll stuff those cartridge filters in that. That, as a health physicist, makes me cringe because now you're creating two different waste streams that can be very problematic because what happens is if those things sit there too long, now you start leaching out stuff into that water, and I can't dispose of a drum full of half solid and half liquid at a landfill. They're going to make you separate it. So now you're pulling the stuff out now, and it just really makes a mess. Then you have the other people that understand that. So they take their filters, and I know you've seen this, and they lay them out on pallets and just let them oxidize in the air. So what happens is that iron sulfide, when it starts making contact with air, turns into iron oxide, and it's an exothermic reaction. When you have one filter sitting there by itself, you can actually watch it. It kind of has a little iridescent look to it as it goes under that change. It happens pretty quick. But when you start getting a pile of these, we've actually seen people burn down their storage bins, and they can really have problems with that. So that's something we keep working with clients, and again, it depends on how much is it in there, because you don't always have the same amount of iron sulfide coming off your line. So that's one thing we always try and work with clients and come up with something that's kind of mutually acceptable between the two of us. Can we just can we mist those and put them into a drum so they're damp enough to keep the temperature down, but not so wet that you're actually creating, 54 gallons of crud water you're going to have to dispose of at some point.
So I always go back to when I was a young consultant, one of my first times in West Texas, and they didn't know, obviously, because they took the filters out, put them in a roll-off, and there was no norm concern at this point either, which I look back, there must have been, or there should have been, right? But all of a sudden, the whole roll-off is on fire, and, the guy looks at me and goes, well, I guess you won't have to take those to the landfill. And I'm thinking, you probably made a worse mess, but...
Yeah, we even call out to clean up fire residue, and you're looking at it, you'll see little pieces of the old cartridge filters. I know what you do.
Well, Don, Chris, thank you both. I learned a lot, so I hope everybody else on the call did. And we appreciate your time.
Enjoyed coming out here and glad to be part of it. And again, if people got questions and want more detailed answers, would love to help you out.
Yeah, reach out, and thank you guys for joining. It was fun.